Hello everyone, my name is Router, and with 6.0's release, I have decided to make the most comprehensive tutorial of logic processors. Now, I'm going to assume that you already know a bit of stuff. Now, one thing I'm going to tell you is that processors, they don't actually execute instructions every second, they execute it every 1/60th of a second, which is why they have values that divide by 60. That's because that's how many frames there are in a second. Naturally, as the speed that the processors run at. For example, we have instructions 120 per second. That just means that uh, you're going to be running 2 instructions per tick. Now, another thing you should know about microprocessors, and really any kind of processor, is that you can link it to something. If you link a conveyor, for example, to the processor, you click on the conveyor, and it turns into highlighted one as if it's enabled. This is called linking, and it'll allow you to access this specific conveyor with the variable conveyor1. When I mean variables, why are we talking about variables first without going into some actual examples? Well, the reason is variables are actually the building block. There are some constant variables, and there are some more commonly used variables, which frankly you have to define yourself. But before we define any of those variables, I need to talk about their size, and that is double. Doubles are 64-bit, except that they aren't technically numbers. When you get a double, you actually get 53 bits and then some bits for the exponent. That's why doubles can store massive numbers and not massive numbers. For example, extremely tiny ones like 0.0003141 and so on and so forth. Of course, and that's just variables. They have 53 bits each, 53 easily accessible ones at least, and some metadata that allows you to look at their size and, yes, this number is larger than the 53 bits. It's just kind of scientific notation at this point. But to start off with variables, I need to talk about externals. Now, what's an external variable? Well, an external variable is a variable that always exists. And here we have a few. And here we have every single external variable that exists. We have add time, which outputs Unix time in milliseconds. This can be used to, for example, cause some timing to happen, and timing is kind of really important, especially if you're updating something asynchronously. And you have add counter, which is going to tell you what line you're on, what program line you're on. Now keep in mind that instructions, like everything, start from 0, which means that the first instruction you place down is going to be instruction number 0. Counter will also be 0. You have also the positional external variables, and those are used mainly to simplify code. It's actually very weird that those were added in the first place, but this X and this Y will allow you to basically not have to do some stuff in order to get the processor's XY positions. Speaking of which, how are the XY positions stored? Well, they're actually stored in blocks. Now, normally, in Mindustry fashion, you would be looking at world coordinates. World coordinates are basically block coordinates, tile coordinates, multiplied by 8. Why 8? Because in old Mindustry versions, and this is for like compatibility and stuff, every single block had 8 by 8 textures, and to better describe that positions, all of the coordinates were multiplied by 8. It's even in the tile size variable in the root and one of the root classes. We also have add this, which will return the building you're currently executing from. This is the fundamental processor feature, because you should be able to sense your own buildings. Because if you don't, well, you can't link the logic processor to itself. Normally, at least. The only way you can link a processor to itself is using something called pre-linking. And that's a bunch of hooey that I'm not going to go into. You also have at links, which is going to tell the processor how many links it has. This is useful for when you want to make something like a reactor system and you want to loop through every single link. This will just tell you how many links there are. So right now there's 0, 1, 2, 1, 2, 3, 4, 5 links, and naturally all of these will be accessible with wall 1, wall 2, etc. But maybe you don't want to make your code extremely long, so maybe just loop through them. And of course you have the final variable, which is IPT. This stands for instructions per tick, and every spoilers, and every processor will have their own IPT. For example, the microprocessor, I've said, has 2 IPT, 2 instructions per tick. The logic processor has 8, and the hyperprocessor has 25. And now to start with some actual code examples. Now I might be thinking, what are the instructions? And this is the whole reason I'm creating this tutorial. Rather, this description of everything. Manual. Alright. This is because microprocessors and literally older processors have some very weird mechanics that you might not know existed, but if this is your first time programming, this would definitely be your worst enemy, because you would have to do stuff. So without further ado, out of the whole 18 instructions that exist, we're going to start off with the first, and that's the read instruction. The read instruction consists of 3 variables, rather 3 configurables. First is the target variable, which is going to be written to, and the second variable is going to be the block that you access from. For example, this could be cell 1, which is going to link to the first memory cell you've connected. And the third configurable is the address. You might be thinking, what kind of address? Because you know that you can place multiple memory cells and you can just store them, right? Well, you can, but it's not efficient. Just store one value each. So if you take a look at the handy info button that no one seems to check, you get that every memory cell will be able to store 64 variables. Now, how do you actually write to those variables? Well, first we need to talk about the address itself, and when you execute something, there is no error checking. There is no error checking. It will just be done. It's on default values. And you can read from any address from 0 all the way up to 63 with memory cells. And that's how you interact with memory cells. Of course, you can't read from memory cells without writing to them. So the second instruction, write, is going to write a certain value to cell 1 at a certain address. Now, even though I say this is a variable, there's nothing explicitly saying it's a variable except that except that it's text. It's a text that you can type in. This is what makes it a variable, because there's no quotes around it, so it's not a string, and memory cells can't store strings anyway, which is one more thing I should have said when describing variables. Ah, damn. Well, I guess I was too slow on that one. But you can write values here. You can write 3.1415926, and it will write into the memory cell. You can also read from the memory cell, but with another processor. That's how you communicate between processors easily. Or, yeah, in time or space. Then you have the drawing instructions. The drawing instructions have 10 different subcommands. I wanted to say 9, but I clearly haven't looked into the draw subcommands in a while. But we have 10 subcommands. We have clear, which is going to set the entire display to color you select. We're going to have color, which is going to set the color of lines you draw, and not just lines, literally everything. We have stroke, which is a very undocumented thing, but it's going to set the thickness of your line. Damn it, Nuke, I thought we were over with that terminology. And we have a line, which will draw a line from XY to another XY, basically between 2 points. Now, I should probably note that displays can't be as large. This is just a relic from the color thing, because color can go from 0 to 255. Actually, let me go back to the color 1 second. That's the whole RG and B value set, but there's this A value. What does it mean? Well, it's actually the opacity, the alpha value. And it's called the opacity because it just is. It goes from 0 to 255, as with all the other color variables. And you can do some very funky shit with it. You can make it output a blue line which is only half visible. Then you can write a green line which does, again, just that. Alright, anyway, back to the line. We never described it, actually. So, let's move to rect, which is short for rectangle. Rectangles are described with 4 variables, x, y, and the size. Note that it is going to draw the rectangle at the bottom left first. So, if you type x and y 0, 0, you would have to define its size. And for example, if I type in 40 and 40, it'll fill exactly half of the display. It's really cool. But of course, there's more. Line rect, which does the same thing, except it doesn't fill the rectangle in. It just draws lines. Then the polygon. And oh man, this is used for when you really don't want a square or a triangle, but you still want a pretty beautiful shape, like a hexagon or an octagon, or even a pentagon. Now, polys are described in 5 variables: x, y, the amount of sides. For example, it could be 2 sides, like a line, 3 sides, triangle, 4 square, 5 pentagon, 6 hexagon, and so on and so forth, until you reach the maximum, which there is a maximum, but I am not sure what value it is. Usually when I want to draw circles, I just type in 100 here, then give it some radius. Now of course you can also rotate the polygons. By default you would have right-facing polygons, and it's kind of a bizarre thing, but when you look to the right, that is how mathematicians define the zero angle, not up like in Scratch. Then you have the same thing to draw with lines, and then you have triangles. You can draw triangles with 3 arbitrary points. They will draw with respective colors. Actually, I'm not sure if it's going to draw with thickness, but it's going to draw a triangle between the 3 points. Note, this is very important. You can't have a line triangle. It would be easier for you just to draw 3 lines instead of just having a triangle line subcommand. And of course, the most complex of all, image. And image will allow you to draw a certain sprite at an XY position. Note that this is centered, which means that if you draw something at 4040, this will be the center point for that image, and you can set its size, rotation, but the default size is 32 because of some font shenanigans. Same thing will apply for polys and line polys, he says, inverting them. But you will be able to draw them, and 4040 will refer to the center because there is no bottom left point to speak of. Now, for the actual kicker, hello world. By default, when you select the print instruction, it appears with frog. You can replace it with any string you want. Note the quotes. We have double quotes around it saying, this is a string. Do not treat this as a variable. And you can type hello world. And it will just work. Right? Wrong. Because while the print instruction is superior, if you try to type, say, null in, or true, which is just a shorthand for 1, thanks Nuke, very cool. Or if you just try to type something else like add copper or add unit, which is again is pretty special, kind of a variable, you would be able to print it. Let me just leave it as hello world. Now I'm going to skip over draw flush a bit and just add print flush. You might be thinking, you already have print and draw. Why would you need a draw flush and print flush? Well, in reality, you're not actually writing to the display, you're actually writing to the buffer, the graphics buffer. And the graphics buffer can be flushed, that means drawn to something. Same with the print buffer. You can write something and then you can print flush it to a message block. Of course, I don't have a message block, but if I place it, you're going to see hello world. Also, you did see some flashing there, but that's because there wasn't a message block and the code was kind of running for a long time, so it couldn't flush, and the buffer just stayed there. And finally, draw flush, which needs only a block, just like print flush. Now, there's also an instruction which people don't normally talk about, and that is the no-op instruction, the invalid instruction. This instruction does nothing, and it's kind of like assembly where you don't really need to do anything. Of course, you can copy it, clone it, and do some really neat stuff with it. And yes, draw flush, just being that. So let's move over to the drawing section. These are all the 10 different subcommands visualized. Now, you might be thinking, well, wait a minute, these 2 logic displays are blank. They're not doing anything. Well, that's actually the color and the stroke subcommands. They still exist. And of course, you can see stuff like color being set to 0, 0, or a line being drawn from the bottom left to top right corner. How am I even able to get the top right corner, you might ask? Well, that's because the logic display has a resolution of 80 by 80. Again, it's in the info menu. Why does no one read this? Then you have your rectangles, your line rectangles, poly, line poly, triangle, and the image itself. Right now it's set to copper, but you can change this to anything. You can set it to be a unit, you can set it to be anything else. But without further ado, let's continue. Now, we have 4 different control variables, instructions, sorry. Now, these will allow you to get a certain link from 0 to at links -1. For example, if I want to take the power node, and it could very well not be a power node, but just in case, you can link reactors, you can link nodes, and if you unlink the reactor like this, the node suddenly becomes the first link, rather zeroth. Now you might be thinking, how can this be used? You can't really write to blocks, can you? Oh well, that's what the next instruction control is for. And that will allow you to do some stuff. For example, you can control whether a block is enabled or not. Now, you can see that there's a block variable in here. But if you used getLink beforehand, you could turn this block 1 into the variable you desire. I usually use the letter L to denote link. And you can set enable to either 0 or 1, which will just enable or disable the block. There are some things you can disable, like power nodes and batteries. You can't really disable them because why would you disable them? I mean, power nodes, they can only link stuff, and batteries, they can store stuff. So you can't really disable each and every one of them. Now, of course, you can make the block shoot if it's a turret, and you can make it target the position X, Y, and if you really want it to shoot, you can set it to 0 or 1. 1 to shoot and 0 to not shoot, just aim. This way you can make a turret aim at your player or at the enemy. And you might be thinking, well, that's useless. I won't be able to use this anytime. Well, this is where you're wrong, because you really can't predict where something will go. Shooting at XY positions will cause you to have some kind of vague control. Like, for example, a player will be able to control it because turrets, they target units, which is why there is a shoot P set. Now, everything's the same, except instead of XY, you have unit and shoot. Now, wait a minute, how can you get a unit? It's obviously not a number or a string, so then what is it? Well, I have a confession to make. Strings are objects, and units are too. So, if you want to get a unit, you're gonna need to do some wacky stuff. One way to get a unit is by using the radar instruction. Yeah. And you can use a block to radar from, and you can use these filters to see what kind of unit you're targeting. Now you can have multiple filters at the same time. By default, any unit will be selected. It doesn't matter if it's flying or not, or if it's a player or not. But you can have the enemy flag, which is the default, and it's going to detect any enemy unit. It's going to detect ground units, air units, any units. But that's because filters stack. course, there are some exclusive filters. Like, for example, you have the enemy filter, which shows your enemies, rather, units that are on the other team. We have ally, which shows units that are only on your team. We have player, which makes sure that the unit is an actual player. It's not just a unit or a logic control. You can also have attacker, which I have no idea what that means, but my best guess would just be that it's a unit that can attack. So, for example, not polys, and something, for example, daggers, flares, horizons, etc. If you don't know what those are, watch my comprehensive tutorial on units, which is coming up soon. Then you have flying units, ground units, and boss units. Now, wait a minute, boss units don't exist anymore. It was removed in version 6. So then what is a boss unit? Well, the boss unit, it's not actually the tier 4, tier 5 chaos array or eradicator. Rather, in the new versions, chaos array, it's the scepter, and the eradicator is the rain. It's not these bosses. It's actually guardians, which you will see in campaign very often. They'll just come to plague you. Then you can sort. Actually, first the order. By having order set to 1, you're ordering from the closest to the processor to the furthest away. So it's going to detect the closest unit you have to the processor. If I set it to 0 or anything else, it's going to radar the furthest unit from the processor. I don't know what this could be used for, because you can't type 2, 3 to get other units. Well, I guess that's how. Well, I guess a nuke didn't implement a system that is smart enough. So you can sort with 5 different filters. Again, you can sort by distance, you can sort by health, and keep in mind that order would just basically mean not just closest or farthest, but in case of health, it would mean highest and lowest. You can also do the same with shields and armor, which are 2 different entities that I won't get into the nature of, but armor is basically the natural resistance, and shields are, well, shields, they can be granted to the unit with something like a pulsar, or maybe just spawn with them in the case of waves. Then you have max health, and this will just output the most tankiest units, at least of the orders 1. And of course, here's your output variable. And just like that, you know what a unit is. In fact, I'm going to take the liberty of setting it to player, ally, and flying. You won't really need more than 3 filters. If you do, well, that's sad. Now, I don't want to place a turret down, so what I can do is use the external variables we've been talking about before. I can use at this x, well, not this x actually, just at this, and it's going to radar from the processor. You don't need a turret. It's going to radar from the processor and find you. Now just let me just place a duo 1 here, and if I link the duo and give it some ammo, you will see that the duo follows me. In fact, it's not a perfect following, because I'm traveling faster than this duo can aim at me. But it will predict where you're going to move. If I set shoot to 1, you can see that it tries to predict where the bullet will go. And it's really clever. You just have to get creative with it. Another thing you could do is you could configure stuff. For example, I can configure the sorter or item source. Now, what can you configure it to? Well, remember the I had copper which we were doing it. So that object is an item. Items are part of content and so on and so forth. But you can configure a sorter to be copper, for example. So let me just type that in. Set configure of sorter1 to add copper. Yeah. And now that sorter will be copper no matter what, because the processor will make sure that it's linking, that it's configuring the sorter. You can do the same thing to sources as well. And just like that, copper source. Now, radaring and controlling is all good and all, but you won't be able to get the X value of a player or a block or really anything. So on Nuke, to interface with objects, he added the sensor instruction. And this is one of the longest instructions. You have a variable, an output variable, which I'm just going to call V. And you can see at copper, because it's kind of content, you can sense it. And you have your own entity. It can be a block, it can be a unit. It can't be a string though. But just in case, I'm going to type at this because this is the only thing we have. Now, microprocessors can't store items, so this will always return 0. And if you get lead, this will also return 0. All the way up to scrap, blast compound. It's not blastcom, it's blast compound. And pyrrhotite. All of this will return 0 because you can't put items into the processor. Yet. And naturally you can sense other things. Because it's not just items that you can sense liquids, and you can sense special variables. This is the monster, because you can have total items, which is going to tell the processor how many items a block has, or a unit actually. And then you'll have the first item, which is going to be useful if you're trying to configure a conveyor. If you give some stuff to it, for example, you have this mess going on. If the first item is graphite, you can turn the conveyor to be going this end, basically doubling as a sorter. But this will return at graphite. Now I might be thinking, this makes no sense. How am I going to return graphite? Well, heads up, it's going to return at graphite, except it's going to write it into the variable. Now you have total liquids, which is the same thing as total items, but for liquids. Well, you can't store more than 2 liquids at once. Wait, that's a lie. Sure you can. There are blocks that require 2 liquids to just exist. And that is the oil extractor and the cryofluid mixer. Both of these require 2 liquids, water and titanium, to operate, which means that you can use total liquids. I don't know why you would use it, but maybe if you want to find out how much liquids there's in something, well, you can do that. You can also sense total power. Now, many people said in Bleeding Edge and Beta that this is broken, do not use it. But total power will just, ideally, it will tell you how much power there is. It's going to tell it to you in power per second. So for example, if this was a node, then you could connect the node to another power node, and this would read 0.0 per second. Cool stuff. But if we give a power infinite to it, it would read 600,000 per second. Just 600,000 actually, because it's a number. Then you have item, liquid, and power capacity. Item and liquid capacity is inherent to things like tanks and vaults and conveyors and cryomixers. I'm not sure what would happen with cryomixers, but rest assured they have the same liquid capacity for everything. So they would probably return 10, I think. And power capacity is only to be used for batteries. You can't use it for anything else. Then you have slightly more specific variables like power net stored and power net capacity. Power net stored is going to tell you how much is stored in the current system. For example, if you add a battery to your graph, it's going to output whatever is stored in that battery, and you can also sense the capacity. More often than not, you'll be dividing this by this, and that's just some cool stuff you can do. Then you have power net in, which is the sum of all production, and power net out, which is the sum of all consumption. The difference between those is what total power really is. And now for some things that units have. For example, units have ammo. It's a value from 0 to 1, and it's not going to matter what unit you are. Octs, for example, also have ammo, and so do monos. But both of these units can't shoot. Of course they don't shoot, but that's just because they don't have any weapons to shoot with. You could sense ammo, and you could sense... Oh. Well, apparently it's not 0 to 1 then. It's ammo capacity, which I think you can easily sense. And you can divide ammo by ammo capacity and get your stuff done. You can also sense health and max health. This should be self-explanatory. Max health is something like a router's 40 max health. If I damage it, for example, if I was Crux right now, well, the router would have less health and it would have the same max health. You can't change it. Then you have heat, which is inherent to reactors. I don't know if it can be used with impact reactors, but rest assured, it definitely works with thorium reactors. You would use this if, say, your reactor is overheating and you want to disable the reactor as quickly as possible. Well, now you can. Efficiency is slightly different. Efficiency depends on the block you're sensing, but there are many different kinds of efficiencies. You have drill efficiencies. Every single one of these is a drill. They'll have their own efficiency. You'll have mechanical pumps. I think they too have an efficiency. Combustion generators, thermal generators, all of them will have an efficiency. Walls won't have efficiency, of course. Factories will. Unit factories might, because of the whole power thing. So will menders, projectors and stuff. But not processors. Of course, you can't really measure the efficiency of a processor, even if you have hyperprocessors, which use liquid, specifically cryofluid. Now, of course, below efficiency you have rotation, and right is going to be 0, up is going to be 1, left is going to be 2, and down is going to be 3. Basically, by default, you're looking to the right and you're rotating by 90 degrees every time rotation increases by 1. 0, 1, 2, 3. We can't ask for more. Of course, that's the block rotation. Nothing tells me I can't sense a unit rotation. And now that is measured in degrees. Degrees, you might ask. Why not radians? Because they're the most universal unit. Well, this is meant to be simple. Radians are kind of complex to deal with. And if you're not a maths major, you won't use radians that often. So you would use degrees instead. For example, if I was to radar my own unit, my current rotation will be somewhere around minus 10. In fact, because we're in version 6 and we have mods, I can type vars.player.unit.rotation, and you can see that, would you look at that, the rotation is 339.5, which is equivalent to minus 19.5. Actually, minus 20.5, because it's 39 at 40. But there are 360 degrees, and we can move on, actually, to X and Y positions, which just return X and Y positions of units or blocks you're sensing. Then you have shoot X and shoot Y, which are going to sense either turret shoot X and shoot Y, or the units. You can do the same with shooting to determine if a turret is shooting or not. It's going to return a value between 0 and 1. And I've already talked about world coordinates. X is going to return the position of the turret in question, or the unit. So shoot X and shoot Y. And now here's a unit-only property, mine X and mine Y. These two properties will comprise minor units, things like monos, polys, megas, pulsars, quasars, and all the core units such as alpha, beta, and gamma. Actually, no, that's all the core units. You can also sense what team something is on. Now, fortunately for you, you won't get a value like at sharded. No, that's not efficient at all. Instead, you'll get a value according to the team all table. So if you're derelict, your team will be 0. If you're sharded, your team will be 1, crux 2, and then so on and so forth until turn 55. Because that's when the teams end. Of course, there's more than that. You have at type, which is going to tell you whether the block is, for example, a duo or it's a salvo. You can do the same thing for basically anything that's... You can do the same thing for basically anything. Now, first item is basically like at type, but it's going to focus the first item. Then you have flag. It's a unit variable which is only used inside of units. Basically, it's like a number which you can just store inside of units. Of course, it's that same double. You can't store objects, you can't store items, you can't store strings. You can, however, write flags to units. One thing you can use this when you're trying to control several units and you have stuff to deal with. Some very important stuff you have to do with, like separating the workflow, maybe something else, maybe like add time to check if this unit has been controlled before in the last 2 seconds, because that's when you can pick up stuff. Fun fact. You can also check when a unit is logic controlled or not, it can also check the unit's name. Now, if I were to radar myself, if I was just a normal unit, I would get string gamma, because that's how you convert a unit type of gamma to the string. But if you radar my specific unit, well, I'm a player, so I'm going to have a name. What is that name going to be? Well, it's going to be this long name, because I am a member of the Union of Soviet Social because I'm a member of the Union of Soviet Mindustry players. Not social, sorry. But this will be my full name, and you could write that to the variable. And there's also, of course, things like config, which will just tell you what item something is configured to. Or in the case of block factories, unit factories, this will be blocks and units respectively. Now, block factories don't exist in normal gameplay, but I imagine that if when you gets around to adding them, well, you can. If you're a mega or a block that can carry stuff like a payload conveyor, you will be able to add payloads onto it. Of course, it's imperative you can add payloads onto things. So blocks will have payload count of 0 or 1, but megas are different. You see, megas, quads, and octs can all carry units. You can count how many units you're carrying with using this variable. And you can also tell what the first unit you're going to drop is, or what block you're going to drop first is. You're going to have payload type. Now, unfortunately, you can't sense the first payload itself, so you can't sense the health, XY position, shoot X and shoot Y. Now, those don't really exist, but you can sense flags and team, and well, those might be useful for people, but you just can't do it. You have to do some very funny business in order to determine it. Now, of course, you can sense @enable and @configure. Now, I'm not sure what the difference between @config and @configure is, but we can take a look into the source code, and I'll do it. And I'll actually do it right now. So this is the source code. If we take a look in the source code, we can see that configure is not actually used anywhere, not in units and not in buildings, because in both buildings and units you use config. In fact, what does config even read from units? Well, it doesn't actually read anything, just like configure. It can't read anything because there's nothing to read. So that's all the sensor has to offer. Oh man, there's actually one more variable I had to tell you about, and that is @unit. @unit is a variable you will get by binding a specific unit. The unit you bind will be stored in this variable, and you can sense it, you can do stuff, very, very impressive things with it. You can check its XY position, you can check its flag, which is probably the more important feature, and basically it's just your unit. You can control it with @control. Now, this is special. Just like @counter, you can write to this variable, and this means that you can store many different units in your program if you really want to. So now let's move on to set. Oh boy. Set will set a certain variable to, for example, this is the variable result, and if I press tab to move to the next position, I can write, for example, true, which is going to write 1, null, maybe @copper or @eclipse. You'll be able to store literally anything in the variable. not anything, of course. And then we also have math operations. Math operations involve from 1 to 2 variables and an output variable. So let me move over to the logic ops section. And you can see that there are a lot of logic ops. Like, an insane amount of logic ops. You would not want. You might be thinking, well, maybe you shouldn't know everything about them. Well, in fact, some of them are extremely useful. So every logic op I have here, aside from a few exceptions, has values 42 and 10. With our previous knowledge, we can print it and send it to a message block right above the processor to see what the result will be. So this is addition, subtraction, multiplication, and division. The next is integer division, which is denoted by 2 slashes. Now, what integer division is, it's basically like division, but it's going to round down, saving you a floor call and just allowing you to store 4 instead. Then you also have the modulo operator, which just tells you if you divided it by 4. If you multiply the 4 by 10 and then remove 42 and then remove that from 42, what number do you get? And the answer is 2. Then we also have exponentiation, and this will work with floating point numbers as well. Then you have equals. 42 is not equal to 10, so it's going to output 0. However, because it's not equal, it's going to return 1 here. 42 and 10 will return 1 because both of these variables are positive. Then you have 42 less than 10, which it is not. Less than or equal to 10, again, it's not. 42 is greater than 10. Sure it is. 42 is greater or equal than 10. Again, it exists. Then we have the bit shifts, which basically multiply your target number 42, by 2 to the power of 10. In this case, I think it's 1024. No, wait, 2 to the power of 10. Yeah, it's 1024. It's going to output 43,008. Might be thinking, whoa, this is not useful at all. But if you want to compress some data into the 53 bits you have, well, this is useful. You could probably just write or read something. And of course, 42-bit shift right to 10 is 0. Why is it 0? After all, we know that 42 is a larger number than 0. Now, this is not less and more. We're actually going to take a look at this. Now, 42 is actually 32 plus 8 plus 2. So if we were to represent it as a byte, this is 0. But this is 32, this is 8, this is 2, 42. Now, I can't help but notice that this is only 6 bits long. If you shift it to the right by 10 bits, well, you're going to see that all of this will be replaced by zeros, because everything else has gone into the unknown domain. And you would find after 10-bit shifts, you would find this number in the remainder, but you can't access the remainder. It's a bit shift. You can't. I'm not terribly good at explaining things. But now we have binary OR. Binary OR is very unique. So actually, we need that message block back. Remember how I wrote 42 as 00, 10, 10, 10? Well, it turns out that 10 is actually 1010. So a binary OR between those two would mean that you would OR every single bit between this, and you would end up with 001, because there is a 0 in between these two digits. 0, 1, 0, 1, 0, outputting 42. Then you have binary and this is a bit confusing this was a bit confusing to me because, well, why wouldn't you just use the AND over here? Well, it turns out that for some things it's better to use binary AND. For example, the same packet compression thing, because I'm making the internet Mindustry and I might actually need this. Then you have XOR, which is exclusive OR. What that does is it's basically plus, but for binary. If we write it down, here's our two values. Now, XOR is going to say, are these bits different? If these bits are not different, it returns 0. If they are, return 1. And you get 32, which is just 1, 2, 4, 8, 16, 32. Of course, you have bit flipping. And I'm not sure what this is all about, honestly. Flip 42, flip 42. Well, let's analyze the output. We're going to learn this together. So, 42 is stored as this number. Yeah, it's getting kind of boring. But what is minus 43? Well, because we're working in a byte space, flipping would be essentially just flipping all the bits. And you might be thinking, what is that value? Well, it's 255 minus 32 minus 8 minus 2. Now, this is actually minus 1, because 255 is minus 1 in binary. And what you get is that this is precisely equal to minus 43. The more you know. You can flip stuff with it. What I'm curious is that, will it be able to flip larger bit values? And by the looks of it, sure it can. It detects the size automatically. And basically, it's like XORing with 255. You will get flips. Then you have the maximum value, which means it'll return whichever one of these is the biggest, 42 or 10. This will return 42. Then we have minimum, which will return 10. And this is where I was a bit confused. We have ATAN2. Now, again, if you're not a maths professional, you won't know what this is. But chances are, even if you are a maths professional, you won't know what that is either. So I've left a message block saying that this is going to find the angle between the plus x-axis and the point xy. So if you have, for example, this is the 0, 0 point, and this is your kind of coordinate plane. If you put a point over here, which is going to be 3x and 2y, actually, that's actually not that good of an example. We have 4x and 3y. The distance between them will be 5, of course, but what ATAN2 measures is the angle between the x-axis and the line between this point, which is, I think, useful if you want to find out the rotation of something. And this is called the two-argument arctangent. And it's really useful in things like games. Then you have DST. which I also had a lot of brain work to do it. Maybe it's some kind of complex function like the discrete cosine transform, discrete sine transform. But it turns out that no, it's actually just distance. It's just square root of x squared plus y squared. And if we had, I wish I hadn't deleted the coordinate plane. But if you put a point over here, then the distance between 4, 3 will be 5 precisely. Then you have noise. Noise is a very interesting operation because it's constant. If we get 42 noise 10, it will output 0.08, which is somewhat translatable. Now, what this noise is a simplex, and it has no seed, it has null. Hyperprocessors will be able to write as well. Now, this is the preview of the simplex from 0 to, I think, 8. Yeah, it should be 8, but we need to take a look at the code. And this is our first code example. We have y set to 0, x set to 0, and basically we have just a massive loop which will plot pixels at x, y, and here's some conversion from -1, 1 to 0 to 55. It'll just work. Essentially, what this means is that black areas here are negative values, and white areas are positive values, gray areas being 0. Then we have this, which is the absolute value. And I put in 42 here, minus 42 to be specific. What it's going to do is going to print the absolute value, which is how far away this value is from 0. So 42. Man, I did not anticipate this to be an hour long already. But then we have the natural log of x, which is ln 42. It's written as log here, but that's because that's some Java notation that I won't get into. But the natural log of x is 3.73, and it's about what you would expect. Then you have the natural log of base 10, of x by base 10, and naturally, it's a bit smaller because 10 is a larger number than e, and thus 10 to this power and e to this power are equal. Now, what is e? Because natural log is kind of not described to people. Well, it's actually this number, if I can remember, 2.71828, 1828, 4590, 45. This is as much digits as I remember of e, and if you take this to the power of 3.7376, you will get approximately 42. You can't put negative values in this because it will return not a number. Or no, I'm not sure which. Then you have the sine, which is again in degrees, cosine, tangent, and the floor, which is going to return what this value would be like without the whole decimal business. So if we write some decimal numbers here, you'll still see that this is 42. Then we have the ceiling, and the last two, the square root, which is 6.48, and the random value. Now, if you're prone to seizures, please close your eyes until I say done. You can see that this is pretty random. Alright, done. So this will output a random value from 0 to 42, inclusive. But of course, it will never land on 0 or 42 because of how floats work. You can use ceil and floor to get more bits of entropy, but that's all of the logic ops. Which means we can finally move to some more pressing matters. and that is the end instruction. Now, the end instruction will basically make a program jump to the beginning, which is basically the same as you've got some code here, then you have jump always to the first instruction. This is what the end is. These two lines of code will be the same. And then you have the jump function, which basically it compares two things. You can do it in operations, sure, but jumps will allow you to do it as well. You can check if A is equal to B, or it's not equal to B, less than B. For example, if A is false and B is true, this would also be true, and you could jump to somewhere. You can also check if it's less than equal, greater than equal, and you can also jump if it's always true. Basically, an unconditional jump. You have some code here, you can jump to it. Although, you can jump forwards and backwards. Basically, you can do whatever you want with this. There's actually an alternative to jump which I haven't actually discussed yet, and that is writing to counter. Now, what you can do is you can type @counter equals @counter plus some value. Now, this could be literally anything. This just reads from counter, but if my memory is correct, this is going to jump 3 lines forward from the line forward. So basically, it's going to jump 4 lines forward. If we add some ends, this will jump to the last end instruction. And finally, we get to the unit binds, to the unit controls. Unit bind will take a random unit of this type. For example, you can take daggers, maces, fortresses, scepters, reins, every unit you could possibly think about, and then you could control it. What should I also say? There's actually one invisible unit which you can't get, and this is the block unit. Now, the block unit is kind of finicky in that it doesn't really exist yet at the same time it does. If you're chances are, if this unit exists, it's 100% being controlled. Or you're in a server with admin abuse, which just creates some blocks. You can control. Now, unit bind is actually going to write any unit it finds into @unit. This means that if it doesn't find a unit, it's going to write no, and if it finds a unit, it's going to write, well, that specific unit to @unit. And moving smoothly onto unit control, moving @unit to X and Y positions. And there's a lot of subcommands you can do, but you can make the unit stop, move to a certain position, approach a certain position with a radius. It's not going to draw a circle, but it's just going to fly to a circle X radius away from where you point it to. Then you can set it to boost. For example, novas can fly, so can pulsars and other green units. You can also pass find, which will make any unit behave as if it was a ground unit with respect to command centers. If you set the command center to attack and you force the flare to move, well, it's going to move linearly as if it was a ground unit. It's not going to ignore walls, even though it can clearly fly over them. It can also rally and be idle at the same time, which means that pathfinding is kind of a niche. Then you also have target, which is the same thing as controlling a turret. Then you have target P, which will target player, actually unit, on someone. you can also drop items to a certain block. For example, you can drop it to a core shard by typing shard1, and it's going to drop one item into core shard. Note it will only affect one unit because what the processor does is it loops over every single unit and it makes them act. Then you can take items. For example, you can take one copper, and you could drop payloads and pick up payloads. This is for megas. Now, payload take. I don't know what this take units variable is, but rest assured it's probably just some kind of flag to check if you need to pick up units or if you want to pick up blocks instead. This will probably be written as 0 or 1. Then you can mine X and Y position, but you have to be within the range. Same for shooting. You have to be within the range of your target to shoot. Then the flag, which basically you can write any value you want to the unit, and it will write it to the anti-unit. So if you want to write 42 to the unit, you can just do it, and you can then sense it with another processor. Basically, you can use processors as beam towers, or more accurately, you can use units as storage media. It will be very hard to do so, but you can. And for polys and megas and stuff and builder units you can build something at specific coordinates. 42, 42, you can build a block, for example, like at router. And actually, this was a bad example. I'm going to type sorter. Now, routers can rotate, so can conveyors, but you can rotate conveyors 1, 2, 3, and you can also configure sorters, for example, at copper. Now, one thing I didn't mention is that you can configure sorters with numbers. You can configure them with 1, 2, 3, 4, 5, all the way up to 15, because that's how much items exist. And of course, you can get a block, which doesn't actually need a unit, but just in case, you can get a block at certain XY position. Now, I don't know what this type is about, because we had an output called building, and this is what you would have variables of. In fact, let's try it. I'm going to print the building at 4242. And you can see that it's null, as expected. But if we turn on the minimap, it's going to show us where we are in relation to the world's origin. So right now we're on 135.34. And it will output still nothing. Interesting. We type 1 in here. This is interesting. Oh, maybe it's an output variable. Come to think of it. It will output the type of the building. It won't actually use the type as an input. Yeah, my bad. I kind of blundered within. And then we also have within, which is basically like approach, but it's going to tell you whether you're inside of the circle or not. But of course, this works with only units, so we can't do anything. Now, you can also radar from the unit. There's actually a hidden turret 1, but it's actually the unit itself. It works in the same way as radar does. And finally, the last instruction, and this is building you can, and this is unit locate, you can find buildings, ores, enemy spawns, or damaged blocks. You can find anything within these 12 types. You can find core shards, you can find cores, you can find things that store, which is probably containers and vaults. I'd imagine why Nuke would do such a thing with conveyors and stuff, even though they can't technically store things. You can find generators, turrets, factories, repair points, uh, command centers, batteries, resupply points, reactors, a subset of generators, but still. A unit modifier, which is basically a reconstructor, and an extinguisher, which is the way of a tsunami. You can also check whether you want to find an enemy building or not, and you can type it, and you can set it to 0, 1, and if it finds a building, and if it doesn't find a building, all of these values will be null, and found will be equal to false. If it does find a building, it's going to output the X position and the Y position and the building that was found. In previous versions, found would directly give you the building. But of course, there's no use now that we have the building subcommand. And what's interesting is that you have different values here. You can find ores, different ores. You can find ores of literally anything. You can find sand ores, you can find pyrite ores, but it won't actually work, even though you can find sand, and you can even mine sand. Now, this may sound like cheating, but you can't mine sand. I'm clicking on it, and you can't mine it. But what logic allows you to do is that even, let's say I'm a unit. Units can mine anything. You can put drills on sand, so why can't you drill sand yourself? And this would be useful in like some sectors which don't have a lot of sand. You could just move to the sand and then just find it. But I'm fairly sure that finding sand would be a pretty broken thing. It might work, it might not work, because last time when I tried to find sand, it just made units not do anything. You can find enemy spawns, which are the same logic as buildings. You can also find damage blocks, same logic as buildings as well. Now, damaged buildings will only find your allied buildings. It won't find enemy damaged buildings, which again is useful. And that's logic, and that's logic for all of you. You can do all of the stuff I just described, and it should probably come to no surprise that I have some programs. Now, what programs do I have? Well, I have lots. We have turret control, for example, which is probably the most hello world of any program you could think of. If I give those duos graphite and then just make an array of them. Now, this processor is slow, so it won't be able to handle all 16 duos at once. You can see that the turrets are rotating one by one. But if you shoot, it will shoot wherever you shoot. And there's no way to target units specifically. But one thing I can say is that you need to be careful if you want to sense shoot X and shoot Y in servers, because shoot X and shoot Y will update every 1/5 of a second. I don't know why, but actually I have some kind of guess. But basically it's related to how servers synchronize players. And while you can see your local changes almost immediately, the server will tell you that, well, all other players are moving at a frame rate of 5 FPS, which is obviously not what happens in the real world. Now, some things to consider: switches are by default enabled. You can use them as bits. Message blocks, you can't read from them because there's no single logic operation that allows you to do that. We have memory cells, which store 64 values, memory banks, which store 512. We have logic displays, which are 80 by 80, and large logic displays, which are 176 by 176. You can also read all this in the info. And of course, that's it about logic. I might have probably described everything. I wonder what I missed. Oh, right. Because version 6 has been in development for quite a while, some people have took it to themselves to draw images. Now, here is a picture of a Nuke's profile picture. And you can see it's very detailed. Well, as detailed as it can be. And it's just written onto processors. One thing you can note is when you remove the processors, you don't actually remove the image, but no one else will be able to generate that image. So if you type /sync, which I can't because I'm local server, you'll lose a nuke, or any other image for that matter. Theoretically, you should be able to write your entire image into memory banks, and then read from those memory banks into the logic displays. This will be kind of a frame buffer thing. Of course, you wouldn't understand any of this, but I have a lot of logic programs. I have many programs ranging from fully functional keyboards to certain measurement devices that I've made, and yes, those do output text. Then you have Paint, you have some programs that from other people, you have some conversions of programs, you have Rick Astley, you have an oscilloscope, you basically have so much stuff that you're literally never going to run out of possibilities. And thanks for watching. I hope you take a look at all the other stuff, maybe make some stuff of your own. And without further ado, I shall now go back to sleep. See you later.